Hello. Welcome to this second regional team meeting of the Ocean Prediction Decade Collaborative Center, West Pacific and Marginal Seas of South and East Asia. And so to start, we will have some introductory talks and welcome words by Swadhin Behera from JAMSTEC. So please, Swadhin. Microphone on the stage is usual skipping device.
Yeah. Thank you, Mary. Good morning, everybody, and good afternoon, colleagues joining online from Asia. It's a great pleasure for me to welcome you all to this second regional meeting for the Ocean Prediction BCC, Western Pacific and Marginal Seas of South and East Asia. It's a wonderful place, and at the outset, I must thank Enrique, the Ocean Prediction team, and the Mercator Ocean for giving us this excellent opportunity. It's a bit unfortunate for colleagues joining online. It's a really nice place, and I hope you are here, and hopefully we'll have another meeting sometime this year or next year, inviting all of you to join us here. We all are here today to discuss several topics related to the research and development of our regional team, the Western Pacific Marginal Seas of South and East Asia, WPMSSC, and I hope through our discussions, we'll understand what we have now with us that we can fully utilize to cater to diverse stakeholders, and also try to understand what are the gaps that we need to fill to further enhance our services to the society. And in that matter, we already know the value of our services for various sectors in the marginal seas and the Western Pacific. We have diverse marine lives hotspots, then fishery, trade and transport, energy, and extreme climate events. All are affecting the socio-economy of coastal regions as well as inland regions, because many parts of Asia and globe are actually related to fishery and transportation. So nothing is disconnected, everything is connected. And that's why we know in terms of economic values, it should be in billions, if not trillions, and that the ocean services can help to mitigate some of those problems. And we know one of the ways to do that is to improve our operational forecasts, operational ocean forecasts. And we'll discuss a lot about that actually during these 2-3 days. And we know that besides these 4-5, we also have ocean health policy and economic development and sustainability. All those related activities will need good ocean forecasts. And for that, we need to understand what we have now and what is missing, so that we can fill those gaps to enhance our products, not only for services to the society, but also improving our knowledge, improving our understanding of the region, the fine scale processes, the physical processes, the biogeochemical processes, and the interlink. And that will help us to develop the services we want to give it to the society. We know that in the last regional meeting, we already have like 10 steering teams. They are not only kind of unique to our region, but also Enrique has ensured same kind of teams in all the regions. The idea is that not only we discuss inside our region, but also we exchange information with other teams, similar teams in other regions. And through that kind of exchange, we can enhance our knowledge and the global knowledge, and also kind of cater to this to the global community through our regional process. And that's the idea. And one of the big and important thing for us is to improve ocean observations. We'll hear several talks today. After our introductory talks, we'll hear several talks on those things, those activities. We know that we have done a lot of progresses in satellite observations, in situ observations, especially by Argo floats. We have a lot of observations now, but we still have a lot of problem, especially in the coastal regions, where the satellite data is not good enough, and we don't have so many observations to assimilate the data and also validate the data. We are thinking of now making ocean forecasts at 200-meter scales. So when you go to 200-meter scales, we need that kind of observations to both assimilate into the forecast system and also validate the results, so that we have confidence in providing those forecasts to various services. So that's why we need improved forecasts, improved observations for our forecast. And that can be done through opportunistic network of observations through some of the regional countries who have resources to do that. At the same time, probably we can also use some of the unconventional observations like biologging, using seabird, sea turtle. Probably you can take some observations which will enhance the observational systems, which we are lacking at this moment. And the second thing we need to improve, of course, is the ocean forecast. We know we have a good system. Several institutes are already doing well, not only in global forecasts, but also regional forecasts. NMEFC and JAMSTEC, JMA, and KIOST, and several other centers, BMKG in Indonesia. We already have good operational forecast system, and I hope by networking them, we can produce a better one for the whole region to cater to different services. We also have like Blue Link in Australia. I know there are some activities in Thailand and also in Malaysia and Singapore. But there are other countries like Vietnam, Philippines, and several other countries who are a little behind in terms of developing operational forecast systems. And there, I think capacity building will come up, and then we'll probably improve the forecast system for each country by working together and developing the capacity and sharing the information. Giving ocean forecast is one thing. Disseminating those information is another thing. So we need a good dissemination system, and we are going to hear several talks tomorrow after the forecast system talks. We'll also hear some of the talks on dissemination, and from those two kind of talks, from forecast to dissemination, like downstream user interfaces, we'll understand what are the gaps, what we have now and what the users need, and then probably we'll try to understand how to fill those gaps by probably developing more interactive interfaces, as well as on-demand downscaling for stakeholders. And once we do that, we'll identify all the gaps and then try to fill them and move to digital twin, probably. One of the ways to kind of integrate all the systems is to use digital twins. Then the issue will come up, I think Enrique will touch on those things, interoperability, and then the data standard. And those things we need to discuss and kind of formulate a common platform kind of things so that it can be operated by all the centers. And then we can use some common kind of outputs so that that can be utilized for some standard services. Like we have so many kind of services which will be dependent on good digital twins, good interface, and good on-demand downscaling systems. Okay, we also know that there are several other programs going on in this region. We will hear two talks after our introductory talks today. One is NEAR-GOOS, a lot of activities under NEAR-GOOS, and the UNEP COBSEA. There are also a lot of activities on the COBSEA. And also later we'll hear something about the Westpac, the IOC initiative in Western Pacific region, Westpac. And they also do a lot of activities on observations and also modeling and forecast. So we'll hear some of those things from them. And then tomorrow, we'll hear about the CNOBS, another Ocean Decade program, CNOBS. And then by understanding what they are doing and what we are doing, I think we can develop some common data platforms, common exchange programs. And through our mutual interactions, I think we can enrich all the programs and improve our activities. So we know big programs need big efforts, and Enrique will ensure that we are on track. We will continue to discuss, and Enrique will provide all the tools necessary to continue our discussion and enhance our activities to improve the forecast, so that by pulling all the accessible information, data, and resources within the region, we can establish a comprehensive information system that not only serves the general public and private sectors, but also bolsters research and development for an improved ocean forecasting and information network, ensuring a brighter future for us. I forgot two things. One is the marine meters, and the other is literacy. So both are also important for future generations. So we need to catch the young mind. I think day after tomorrow we are hearing several talks on marine meters and also the literacy, ocean literacy. And I hope by catching young kids in schools, by educating them and bringing them together with our information system, we can be able to help the next generation to understand what is happening now and what they can do to make their future brighter and the environment better. I'll stop there. Thank you so much.
Thank you, Swadhin, for setting the scene and inspirational talk. And we can move to Enrique. There's a mic.
Thank you. Thank you, Marie. Thank you, Swadhin, for the wonderful introduction to our journey. I have to say that I'm really happy of being here today with this regional team, which is the first one in preparing the steering team, a comprehensive steering team with people from key institutions. So I want to especially thank Swadhin for the very active work he has done during these months. And we are very, very well in track. And I think that the mapping that we are going to do these days of the situation in the region, plus the additional discussions that we will have during the evenings on how we organize the work for the future, is going to mark a leading edge for the rest of the regional teams. So I'm really looking forward for these 3 days that start today. So my presentation will be, first of all, a little bit about OceanPrediction DCC, just in case somebody is a little bit unaware of the whole concept. So I will do a brief introduction of what we are trying to do. Then I will update on where we are, basically our activities on community building, our activities in ocean literacy, and the technical component work that we are developing. So starting from the beginning, what is this DCC, this OceanPrediction DCC? We have to summarize what we are trying to do in one single slide. That will be it. What we have on the left is the ocean forecasting we have today. We have useful systems. We are proud of the systems because we have been developing these systems during the last 20 or 30 years, and they are being used for many practical applications. But we have to admit there are some limitations on what we are doing. Somehow the systems we are developing are technically disconnected. We are not using common tools. We are not using common standards for many of the things. Every time somebody has to develop something, he has to start from scratch. And that makes complex systems that are difficult to implement in institutions that are not technologically advanced. So we don't have the right connection. We work in very isolated ways still today. So we want to change from this scenario to this other one on the right. In the ocean forecasting we want. In this scenario, we have many more systems around, and we have more systems because they are more easy to implement and they are more easy to sustain, because we have the right tools to do this. We have the right standards to implement. We have the right set of instructions for people to implement these systems. We have the right capacity building for these systems to be implemented and operated. And on top of that, those systems will be more robust and will be based on more thoughtful validation systems and this kind of thing. So we want to do this huge transformation, and for doing that, obviously the framework is the ocean decade. That's our captain, the ocean decade, in this analogy with the vessel. Sorry, there was a problem with the presentation. Thank you. The action is going to be taken inside the decade, so decade action will be very important. Also will be, as Swadhin was mentioning, the arrival of the digital twin that will be critical for improving our interoperability. Who is going to do that? Who is going to be with us? Is the OceanPrediction DCC community. This is us. This is the people that we are meeting here today. This is the regional teams. This is the crew that we are going to have to do this transformation. And our role at OceanPrediction DCC in this analogy is to set the course, saying where we are and where we have to go, and serve as inspiration for our collaborators in the framework of the decade to do this transformation. So we have two pillars, two fundamental pillars to achieve this goal. First of all is the community. We want to build a global and transversal community that will be promoting the implementation and use of ocean forecasting systems worldwide. In order to do so, we thought we cannot reach everywhere from Toulouse, so we have to build regional teams that will allow us to be influential, to have collaborators, to have impact in all the parts of the world. So we are building a very decentralized organization with these regional teams. The regional teams will have a lot of weight in our activity and will be the fundamental the fundamental pillar of what we are going to do in terms of community building. We want to build a community that is not, let's say, the traditional one, only formed by scientists. We want to involve users, we want to involve private sector, non-governmental organization, everybody talking to each other and everybody learning from each other. And for doing that, we have get inspiration from UNEP regional seas, GOOS regional alliances, taking the best of both worlds. And we have built our own set of regions, and we are now in the meeting of the first one, the West Pacific region. So once this, the target is to have this structure ready by the end of the year, and we are in good track to do that. And once this structure is on place, this structure will be our boots on the ground for several kind of works, like identifying and attract a wide community, as I was mentioning, support decade action, of course, like the programs that Swadhin was mentioning, identify gaps and way forward, capacity building activities, and linking with the second pillar, advocate for the implementation of best practices, standards, and tools. This is linking with the technical pillar, which is the second pillar. So as I was mentioning, we are proud of our system. We have done a lot during this last decades, but our systems somehow are technically disconnected. And you can see this in all the phases of your system. When you are implementing the system, if you are new into this, you have not the right information to develop it. You have to do a lot of research on your own. You have to read a lot of papers which are not well connected, and you have to build a lot of tools from scratch because you don't have the right set of tools and standards. You have some of the tools like the numerical models. Yeah, numerical models are there, but you don't have other tools ready to develop from scratch. So if you are able to do it, if your institution is rich enough, to sustain the system, pay you for several years while you learn, then your problems are not ending there, because you ended with a system that is probably isolated. You don't have the right connection, you don't have the interoperability with other people, you don't have the tools to exploit proper your system. So what we want to do is to use the opportunity of the decade to change fundamentally this situation. So decade is a game changer, as it's going to be the digital twins. So what we are, how we start this transformation, we have to start somewhere, and we have decided that the best way to start is to define the technical framework. And how we define a technical framework? By defining an architecture on how this system should work. So we built an expert team, which we call the Ocean Forecasting Co-Design team, that is working now in defining this during this year, and we are doing quite well. We are quite advanced in this task, in defining a new architecture based on data standards and tools in cooperation with decade programs, and this architecture will be as a base to inspire decade program development targets. That's the idea. So I will tell you later about this architecture and the work that we are doing in this Ocean Forecasting Co-Design team, that is the implementation nowadays of this second pillar, the technical pillar. So some update on the activities we are having. Let's start by the community building. As you know, as Swadhin explained it in a slide with a much nicer graphic than mine, I have to say. We have the different regional teams on the different areas, and we have the same expert in each area: observation, physics, biogeochemistry, climate. And the idea is that they will be able to talk to each other, forming a global network of experts on each topic, as you can see on the slide. So the role of these experts will be critical to act as focal point in the region for their topic, to network with other experts, to provide new ideas on how we should evolve, to support the mapping activities of ocean forecasting, to work on the gap detection activities, to contribute to the communication, to the building of this community, expanding the community, and support the capacity development and ocean literacy. So there are many tasks that are going to be based on the activities of this steering team. This is a very important component of what we are doing. So what we are doing is building all this regional team, and this is the status today. This is the update of where we are. You see on the left the different activities that we thought were needed to finish before the end of this year to have the regional teams in position. You see on the columns the different regional teams, and you can see that we are doing quite well in most of the region. We are a little bit more delayed on the Antarctic regional team, but we will progress soon on that also. And basically all the regional teams are ready or almost ready to start operations in 2024 once we have all the steering teams in position and once everything is set up equally in the different regions. So this is advancing quite well, and we hope to achieve the objective of having the regional teams ready by the end of the year. Just to mention that we have chairs in all the regions. You can see here all the very important and very kind people that accepted to work with us, starting with Swadhin on the Western Pacific regional team. So this is already achieved. The regional teams, steering teams, are on the way to being finished on all the areas. This is a list of names. As you see, we have always the same, and as I mentioned, the same topics. And this is a transversal structure. So the guy on observation can talk with the guys on observation on the other regions. More advances. We are close, certainly before the end of the year. We are a little bit delayed with this. I thought by this meeting that was going to be launched, but unfortunately this is still not the case, but we are advancing well, and it will be done before the end of the year for sure, on the launch of the web page. This is how the web page looks like. It's no longer a fake. It's actually on test phase. It's not public yet, but it's done and it is working, but we are still fixing a few details. So this is how it looks like, and it will have very, very important tools for us to operate and to work. So it's more than just a web page. It's a set of tools that will be fundamental for our operations and for our work. So we will have the atlas, where we will see all our activity, the forum, the news, resources, and other stuff. So starting for the atlas, this is how it will look like. Basically, you have these bubbles, these points marking the models that are operational in the world. This is still not real data, so don't worry, we don't have a model in the middle of Africa for the ocean. This is just the concept. And when you click on one of these bubbles, you see the actual domain and you see who is behind that, and you have a lot of data about this model. So this will serve to map all the activities. You have also many ways to filter by size of the model, by a kind of model, by institution. You can filter and navigate. It will be really an excellent point for matchmaking between all of us. Then we will have the same in the same atlas. We will have information about the persons that are on the ocean forecasting, on the ocean prediction DCC community, with all the data about affiliation, everything that is typically required. And finally, very important is that the information will not be introduced by us; it will be introduced by you. So there will be an interface, so you can introduce the data and maintain the data up to date. So this is fundamental for the sustainability of this initiative, because this is the way we will guarantee that the information is updated. So this is how the interface for introducing the data looks like. Then we will have the forum. On the forum is, let's say, a classical forum. It's looking a little bit modern, maybe a little bit too much modern, but okay, we will get used to this look. And we will have their community announces, matchmaking services, announcements related to ocean forecasting activities, regional forum activities, everything what is about the ocean prediction DCC will be centralized around this forum. That will be a key element for the building of our community, and we have to make this a very live tool. Then we will have a news section. We have today a database of almost 2,000 persons that have shown interest in being involved in these activities. So this is a very good focal point for showing our activities. And the TÜVS guide, I hope you are familiar with the TÜVS guide, will be converted, and it's already done, into a wiki site, so we can maintain the TÜVS guide as a living document, and we can create every 2-3 years new version of the TÜVS guide with updated information. Finally, we will have a section with virtual halls where institutions can go more in detail, describing their own system, their own activities, and this is like a permanent exhibition for the institutions that want to be highlighted and that want to show in our webpage their activities in more detail. So about capacity building, next thing is where we are here with respect to capacity building. We are in this year basically building our plans for the future. We have decided that there are like 5 steps to go in capacity building. In 2023, we are working on the first 3 steps, which is mapping the situation, basically, engaging the stakeholders, looking what is outside, and design a solution. And we are in this process now. And what we found is that we want to really do our activity based on this scheme. What you have here in this inside the, I don't know if the laser is going to work. Inside the green box, you have the capacity development activity, which is going to be based in 2 main pillars. On one hand is the TÜVS guide. The TÜVS guide will be like our theory book. And then on the other hand, it will be based on our architecture, on the ocean prediction architecture. And I will talk about that in the next slide. This is the result of the ocean forecasting co-design team. So this architecture will not only be useful for technical purposes, but it will be very useful for capacity development. So we will have on one hand the TÜVS guide as a theory book. We will have the architecture as the practice book on the other hand. And having these two, we will be able to develop the architecture tools, implement those, and by doing that, we will be able to start delivering as one and to improving this interoperability that we are searching. The result of that will be better knowledge, better tools that will feed back again on the different versions of the TÜVS guide and on the architecture. So this is the basis of what we want to do. That means that we don't want to do, let's say, a random capacity development, but we want to do a capacity development that is fully integrated in our whole vision. Capacity development, which is oriented to help people delivering as one. This is why this diagram is so important. So with respect to these technical activities, we have built the ocean forecasting co-design team. For doing that, we looked into the ocean forecasting value chain, and we find experts in every step of the ocean forecasting value chain. And we built a team with 42 experts worldwide that have been working in several steps. We are very advanced, and we are in step 5 now, really finishing the definition of the architecture. I think it's basically done now at this moment. And on the step 6, we will wrap up the whole thing and try to define ways forward. So very briefly, some of the results we have found on the way. We have done some gap analysis and some diagnosis of where we are. And this is how this has been recently published on a paper. And this is how it looks like. What we have found is to ask both the experts and the users how good they feel our models are to serve for the purpose. Are our models serving the purpose? And we have found very interesting things while doing that. You can see the different categories: current, sea level, ice, waves, and you can see also on the files the global, regional, the coastal scale, the spatial scales. And not surprisingly, the experts believe that we are not doing that well on the biology modeling, doing just so-so on the geochemistry, and doing much better on the physics, on the different kind of physics. And it's also very interesting to see that for the global, we are quite happy, but the closer we get to the coast, the experts think we are not doing that well, which is quite interesting. If we combine this with the use of the models, this is how the experts think the models are used. We see that on the global scale, we have applications, but not that many. And when we go to the right and we find more and more closer to the coast, the more and more applications are needed and available. So it's very interesting. The experts believe that we are not doing that well exactly where we need the models, which is on the coastline. That's interesting. And to complete the study, we have asked the same kind of questions to the users. And to our surprise and satisfaction, the users are much more satisfied than we are. So the users believe that we are doing in general pretty well, even including biology modeling, everything. We got close, I think, close to 200 replies. So it's very representative survey. And you see the scores are very good, generally much better. They are nicer than the experts when evaluating the system, which is great. Also, I was telling you that we have finished almost our work of definition of the architecture. To understand the work we have done, you have to start here. We have defined 3 main blueprints for the architectures, depending on the role of the digital twins. On the first one, we don't have digital twin on the architecture, but the systems are still interoperable. This is very much what we are doing in Copernicus today. It's the same kind of architecture we are following in Copernicus. In the second one, we have digital twin, but the digital twin is like an intermediate layer for improving interoperability and in facilitating the inclusion of tools, artificial intelligence, and so on. And the third model, OceanPrediction C, is where the digital twins are leading the whole process, including the numerical modeling. Is where you have the numerical models embedded in the digital twin. So with these 3 in mind, we can define the different processes, and we have done many of these plots to define each one of the process inside the value chain. And I'm not going into the details. This is one of the plots to show how the observations are integrated into the value chain. So this is the very first one, from observations to observation properly treated to be integrated into the value chain. And we have defined it in green, the tools, and in blue, the data standards that we will need to develop. So there will be some critical data standards that will be the starting point for our development in the future. It's not working okay. So when we talk about data standard, what are we talking about? This is exactly, we ask ourselves, what should be a data standard of ocean prediction DCC? Because it's not a trivial question. What do we have to put inside? So we came with this answer. First of all, we have to follow the FAIR ideas. findable, accessible, interoperable, and reusable. And then we have following ETL conventions also to have several things into an ocean prediction data standard. First, we need a file format. File format could be NEAR-CDF, for example. Then we need the metadata. We need the lexicon, the definition of vocabulary. When we are talking about SST, what is SST? It's far from trivial. And then we need the storage organization. Are we putting, for example, the sea level data, every daily data in one single file? How we are storing the information? If you put all this together, you define this properly, and you put on top of that an API to access the data, then you have an ocean prediction data standard in the way we want to build. So this is what we want to start working with the community, and we want to advance in defining these ones for the ocean forecasting. And also we are talking with other decade actions related to ocean observing, so they follow the same philosophy, and we start working on the same for observations. But this is to be seen in the future. So as conclusions, we hope the ocean prediction DCC community will be a key element for the development of the ocean we want. Certainly the regional teams will be a key element for the success of these activities, supporting capacity development, promoting the adoption of tools, standards, and best practices to deliver as one, as I mentioned it, based on this architecture that I described. 23 is the implementation year. We will have the new webpage, the tools, the design of the capacity building activities, the regional team set up, and 2024 is the year where we hope we will really start working. We will really start with the cooperation of all the regional teams, developing these standards, starting there, agreeing finally on this architecture, and so on. So the ocean forecasting of the same team in the technical part is one of the key elements to advance towards this definition of an architecture to deliver as one. And I hope this gives you a good framework of where we are, what we have done during this year up to now, what we want to do from here to the end of the year, and where we are going to start in 2024 to develop these activities with the regional teams, the architecture, and so on. So thank you very much for being there. And Marie, the floor is yours again. Thank you.
Thank you, Enrique. We have 5 minutes. Do you take questions from Enrique and Swadhin, maybe?
Is it possible to have questions?
Yes, there's a question here. You?
So I have been working with ocean modeling for more than 20 years. And at the same time, I'm working with engineers and like geophysicists who are mainly using commercial softwares. So their approach is quite different from most ocean modelers. So my question is, will we get there anytime soon? Should we start from the scratch every time? So if, let's say there are some models and they update, and then sometimes we have to sort through options. Are there some changes we have to adopt, something we have to discard? And it takes a lot of time to sort out what happened in a newer version. But the engineers who are geophysicists, who are working on like oil fields, they just use available softwares, and it seems to me that they got what they want. So should we adopt that kind of approach at some point? Like,
well, I think
I'm not sure it's a proper question, but
yeah, I think I got it. Well, first of all, you have to consider that what we are doing here is to find, let's say, a framework to integrate all these things, and we cannot develop a framework to deliver as one if we don't have at least common entry points and common definition of some very basic things. This architecture is not designed to be a tool that will be suddenly implemented everywhere. This is not a realistic thing, and we don't want that at all. But it is something that on one hand will have high value for capacity development and will have a high value to help us to deliver as one. So if we are able, thanks to this capacity development, to define the entry points into the systems, even if there are other systems, not this one, they could use this in the future, and we will advance a lot towards this target. So I hope this replies a little bit your question.
Okay.
Thank you, Enrique, for your comprehensive introduction on DCC and your outstanding leadership. Based on my understanding of the structure of the DCC, the steering team and the co-design team are two players for the implementation of the mission of the DCC. I'm kind of a little bit confused between the mandate of the steering team and the co-design team. Are they overlapped, especially for the members, this at the level of the DCT? And also, my little bit confusion is about the co-design team under the global DCC and the regional DCC. And you just mentioned the regional DCC also have their regional co-design team and all the steering team. So all these teams are under the architecture of the global DCC and also the regional DCC. I'm kind of not quite clear about their mandate, and maybe there are some overlaps between the mandates and members.
Okay. So maybe I was not very clear. I was fast on the explanation. There are basically two, let's say, semi-independent pillars, which should not be completely independent because there has to be communication. But let's start thinking that they are independent pillars. One is the technical pillars, and the other one is the community building pillar. The technical pillar is going to be led by the ocean forecasting co-design team, especially now at the beginning when we are doing this work of defining the architecture. So this is the main goal of the ocean forecasting co-design team is working on this definition of the architecture and identification of gaps and forwards. And the main role of the regional team is the organization of the activities at the regions. So these are completely different tasks. Most of the members of the ocean forecasting co-design team are not in the regional teams today. So they are quite different people in person. Sometimes there is a coincidence of one person that is in both places. So they are not overlapping in terms of person. So once this is defined, it's also true that we cannot isolate both pillars and they have to be in communication. This is why, for example, every time we have new results on the ocean forecasting co-design team, we distribute this to the regional teams, so you are aware of that. And if you want, you can put your opinion on top of the table and you can participate into it. But these are, let's say, the two different tools to achieve the two different objectives, the technical infrastructure and the community building. I hope that clarifies. Thank you.
Okay. So maybe we can move to the next presentation, which will be online by Dr. Pradhan from NMEFC, presenting NEAR-GOOS, and Dr. Mahesh Pradhan from COBSEA. The joint presentation? Okay. You are online. Okay.
Thank you, Marine. First, I'm going to share my screen.
Please share your screen. We can see you, we can hear you now. There are two talks, okay.
Can you see my screen now?
Okay, we can see your screen perfectly.
Okay, thank you. Good morning, everyone. I'm Renbo from National Marine Environmental Forecasting Center. Dr. Guimi Liu, the chairperson of NEAR-GOOS, is in a business trip, so she asked me to represent her to introduce NEAR-GOOS. The Northeast Area Regional GOOS, shortly called NEAR-GOOS, is a regional pilot project, or GOOS. It was established in 1996. It consists of 4 member states of China, Japan, the Republic of Korea, and the Russian Federation. NEAR-GOOS is led by the NEAR-GOOS Coordinating Committee, which has 8 members from 4 real-time databases and 4 delayed mode databases of its member states. Dr. Guimei Liu is the chairperson of NEAR-GOOS Coordinating Committee. NEAR-GOOS is supported by the IOC Westpac office. Under NEAR-GOOS, there are 3 working groups. Working Group on Development of Operational Ocean Forecasting System aims at developing operational ocean forecasting systems of NEAR-GOOS member states. Working Group on Product focuses on unifying and improving forecast products. Working Group on Data Management is in charge of observing data management, checking and reporting status of NEAR-GOOS databases. Pilot project of Climate Monitoring Section focuses on coordinating joint observation by ship between Japan and Russia. Pilot project of Ferry based on monitoring is for coordinating observation in business ferry between South Korea and Russia. The objectives of NEAR-GOOS are divided in 2 phases. The objectives in first phase to facilitate the sharing of oceanographic data and develop a basic integrated ocean observing and operational forecasting system has been completed. Now, NEAR-GOOS focuses on developing a comprehensive and sustained ocean observing network in the Northeast Area regional seas.
Sorry, Dr. Pang, sorry to interrupt. We have an issue with your slides.
Okay.
There's something wrong. They don't show as it should. Maybe can you try to go back to the slide you were talking on and share it? Ah, we have the backup. Okay, we have a backup solution.
Okay, could you share the screen for me?
Yes, we will do this. Just give us 1 minute, 1 second. We'll do this for you. Vas-y. Okay. Okay, so now your screens are online. We go back to slide on the objectives.
Okay.
Previous one. Encore. On revient sur le 3.
This one?
No.
Yes.
On the objectives? Okay, good.
Okay. So the objectives of NEAR-GOOS are divided in 2 phases. The objectives in first phase to facilitate the sharing of oceanographic data and develop a basic integrated ocean observing and operational forecasting system has been completed. Now, NEAR-GOOS focuses on developing a comprehensive and sustained ocean observing network in the Northeast Area regional seas and coastal regions. Next slide, please. Each member state of NEAR-GOOS has 2 ocean observing data sharing portals. One is national real-time database. The other one is regional delayed mode database for sharing observing data with different timelines and data quality. This data can be free and openly accessed, but there is a slight change for Russia recently. It temporarily need account application from users and further approval from Russia to download real-time observing data in Russia. Next slide, please. Real-time observation data of 37 observing stations, 8 buoys, and 1 radar is already updated on real-time databases of NEAR-GOOS. The location of these observing tools is shown as the photo at the left bottom. It includes meteorological observing variables and the oceanographic observing variables. To provide better sharing service, we developed a NEAR-GOOS gateway website supported by NMEFC of China as the photo at the left bottom. It integrates metadata of observing tools, downloading links of observing data, and forecast products from all NEAR-GOOS databases. Now, this website has been developed and will be in operational service in the future. Next slide. There are much more variables and data types with higher quality in delayed mode databases than real-time databases in NEAR-GOOS. Here is a success story of data sharing on delayed mode database of NEAR-GOOS operated by GODC of Japan. The total volume of oceanographic and meteorological data available on RDMDB has increased about October 2021. There are 59 types of data in RDMDB of NEAR-GOOS in Japan. The highest number of hits on the website of RDMDB of NEAR-GOOS in Japan is over 37,000. Next slide, please. Ocean forecasting products are shared daily by 4 member states of NEAR-GOOS. For example, wind, current, temperature, and wave are separately provided by agencies of South Korea, China, Japan, and Russia. Next slide, please. Here is a good example of forecast products sharing. As the RTDB of NEAR-GOOS in China, NMEFC published current, temperature, and salinity once per day, and wave twice per day. The forecast period of all products is 7 days. From January 1st, 2023 to October 7th, 2023, the total number of products is over 9,000, and the total data size is over 7 gigabytes. Next slide, please. Here is a success story of synchronized observation carried by Japan and Russia through the NEAR-GOOS pilot project of climate monitoring section. The blue line in the middle right photo is surveyed by POI of Russia, and the red line is surveyed by GMA of Japan. The oceanographic and biogeochemical variables are observed by CTD and water sampling. After the survey, they are going to exchange observation data and share them in NEAR-GOOS. The survey has been conducted 11 times from 2011. New findings like warming trend of bottom water have been found and analyzed through this observation data. Next slide. The NEAR-GOOS Coordinating Committee session is organized annually. As one member of GOOS GIAs, the chairperson of NEAR-GOOS attended GOOS GIA Forum. Under umbrella of IOC Westpac, we also attended its intergovernmental sessions and scientist meetings. As an important partner of PACIS, the chairperson of NEAR-GOOS represents NEAR-GOOS in its annual session. Next slide. That's all. Thank you. Thank you, Marie.
Thank you. Thank you for this talk. Do you have any questions? We have some minutes. Any questions? Yes.
Thank you for the presentation. Is the data between Russia and Japan available to the public? Near the end, you showed a joint observational program between Russia and Japan. Are the data available to general public, or it's only to the scientists related to the project?
Now the data is only shared in the NEAR-GOOS, and it's not published. It's not accessed by the public.
Okay, thank you. And maybe another short question on, do you already agree on formats in this regional alliance? Did you hear my question? Sorry.
I have heard your question. What do you mean the data format?
I mean, do you already, well, I see you can share, you share on a regular basis, you share forecasts, outputs and observations. And did you already agree on a way to share things, standards and formats and way of doing things?
Actually, we are working on the unified data format and the unified format of forecasting products. That's why we established 3 working groups to work on it. Now it's in the process.
Okay, thank you very much. So now we can move to the next talk. So it will be given by Mr. Mahesh Pradhan. So you will explain us what is COBSEA. So can you share in full screen, please? Yeah.
Yes, just a minute. So can you hear me?
Yes, we hear you very well.
Okay.
Yes, it's working. Please.
Excellent. Yeah. Thank you very much. And good morning to all colleagues sitting in the room there in this beautiful venue, as was mentioned earlier. And greetings to over 100 colleagues online all over the world from Bangkok, Thailand. My name is Mahesh Pradhan, and I'm the COBSEA coordinator, which is part of the 18 regional Cs. This is something that Enrique also referred to in his presentation. There are 18 regional Cs programs globally. And in fact, next year, 2024, will mark 50 years of these regional Cs programs. There are different levels in terms of some are full-fledged conventions, whereas some, like COBSEA, is an action plan. Just also following on the last presentation, we have NAUPAP, which is the Northwest Pacific Action Plan, dealing with the very same 4 countries, China, Korea, Japan, and Russia, which is also looking at marine issues. But again, I think I see a lot of complementarity between the efforts on the DCC as well as with the regional Cs programs. Coming into COBSEA, the region that I am responsible for, this was established quite a while back, 1981 to be precise. But the East Asian Seas Action Plan was updated in 1994. Again, it's an intergovernmental mechanism bringing together 9 countries. So in fact, with NAUPAP, we overlap with China and the Republic of Korea, plus 7 ASEAN countries. We cover quite a number of these large marine ecosystems, LMEs, as in this sort of definition, starting from the Gulf of Thailand, the South China Sea, as well as the East China Sea and the Yellow Sea, but also the Indonesia Sea and the Sulu Celebes Sea. The Secretariat is located in Bangkok, and currently we have focus around 2 themes. So I wanted to share these thematic areas in terms of the colleagues that are online to see how we can perhaps integrate. Marine litter and plastics, that's one. And then the biodiversity, the marine and coastal ecosystems. We're also starting on climate, and I was very interested to hear the presentations before. But in terms of plastics and marine litter, and many of you are aware that there's a new global treaty that's being negotiated on plastics and marine litter. 2 rounds of international intergovernmental negotiating committees have taken place. And the 3rd one next month, 13th November, will start in Nairobi. But an ambitious target to have a whole new treaty on plastics ready by the end of next year. In fact, Korea will host the INC5, the Intergovernmental Negotiating Committee, next year. But as you can see in this sort of chart, there are a number of different intergovernmental mechanisms, and it's quite complicated in terms of the overlaps as well as the synergies that should be in place. Obviously, for us in COBSEA, ASEAN is key because we have, out of the 10, we have 7 that are participating in COBSEA. But then you can see the overlaps with the other different mechanisms like ASEAN +3, the NAOPAP, and the East Asian Seas. But on marine litter, and this is where data is something that's being generated constantly, and it's something that's quite a big gap, perhaps for consideration in terms of servicing this very important data need, is that we have an agreed regional action plan on marine litter, looking at 4 areas, sort of land-based sources, so the source to sea runoff, then the sea-based sources, which doesn't get enough, I think, attention, in my opinion, with ghost gears, the abandoned and lost fishing gear. But then in terms of monitoring and assessment, how do we harmonize monitoring? Because plastics, microplastics, it's quite varied. And I think this is one area that needs quite a bit of strengthening. And then finally, the knowledge sharing in terms of the different platforms that are there. And here we at COBSEA host the East Asia node of the Global Partnership on Marine Litter. And within that, there's a very nice database, and I want to share a few slides with you so you have an idea of that. But then we also have several pilot activities where we generate data and as well as try to see if these can be replicated. This is the Global Partnership on Marine Litter, just the landing page. The URL is on the top, as you can see, and I encourage you to please have a look. And within that, this platform draws on quite a number of databases that are out there, like the Global Plastics Watch, the NOAA Marine Microplastics Database, the International Marine Litter Database, and it kind of brings everything together. One example I'd like to share the screen with you is on this environmental and biota impact. And this is just showing the transport arrangements between the different countries and the possible contribution to marine litter flows. In the case of COBSEA, we have also established a regional node where we have a data platform focusing more on research at the moment, looking at the policies that are there. Many of the 9 countries have national action plans and roadmaps, but then we want to see who are the scientists, what is the marine litter science out there, what are the research networks, and how we can connect. And here, for example, we have, with the help of the National University of Singapore, put together this research database where we have 193 resources, a lot of interesting publications that are out there in this increasing field of marine litter and plastics. Just to show you an example of Thailand, where there's 64 sort of online publications looking at different aspects from microplastics to macroplastics to fishing gear to science-only focus, as well as on policy. Moving on to our second area of work, which is on the biodiversity. And as you know, last December, we had the Kunming Montreal Global Biodiversity Framework. Again, very ambitious targets leading up to 2030. And again, this aligns with Enrique and his presentation of the OceanPrediction by 2030 we want, where there are these 23 targets, very broad ranging in terms of coastal spatial planning, restoration, as well as conservation, 30 by 30, 30% by 2030. Again, blue economy, the overall framework, but looking within that, marine coastal spatial planning, as well as protected areas, and then habitats themselves. And in this context, I wanted to share with you the UN Biodiversity Lab, which is again a joint effort between UNEP, UNDP, the Convention on Biodiversity, as well as one of our partners, the UN World Conservation Monitoring Center in Cambridge, that puts together quite a bit of information related to nature-based solutions, protected areas, and also ecosystems restoration. And as you know, in addition to the UN Decade of Ocean Science, we're also right in the middle of the UN Decade of Ecosystems Restoration. As you can see, there's quite a lot of resources out there in terms of data layers, 400 plus, and then 35 million that have actually used it in terms of impressions. Just again, a snapshot of one of the pages within this biodiversity lab, looking at marine protected areas. And here it shows you, at least within the COBSEA region, where we have strict nature reserves, national parks, as well as protected areas in terms of landscape or seascape. Again, quite interesting. The yellow dots also show you the coral reef connectivity. And for us in Southeast Asia, coral reefs is very high. I think we're mega diverse in terms of coral reefs and the location of these coral reef hotspots in the region. But with that, I would like to also share a couple of slides on UNEP's GEMS, which is the Global Environmental Monitoring System, GEMS Ocean, which has been going on. Again, Mercator is again one of the partners in this, as well as our colleagues at UNESCO IOC, where there's been quite a number of activities that have been taking place. The focus has been on transdisciplinary partnership, but also looking at strengthening capacity on ocean monitoring. But then in terms of access to and use of quality assured open environmental data, this is currently looking slightly at its formative stage. And I think together with DSS in terms of the future from 2024 onwards, how the data can be used, uptake, and then scaled up, I think is the plan for GEMS Ocean. There is 6 thematic working groups, and these are cross-cutting from capacity development, data services, emerging issues and foresight, interesting paper on sargassum for the wider Caribbean region, engagement and communication outreach, policy support, and of course, ocean observations. This, I think, is again taking shape, and there are a lot of good scope for synergies. And I would like to end off with the UNEP's World Environment Situation Room, where there is a lot of focus on not just on oceans, but looking at air, water, land, and this triple planetary crises of climate change, of pollution, and of biodiversity loss. And in fact, recently, which is featured here in the Caribbean, there was a hackathon, which we're hoping that in the context of COBSEA, we can also replicate. We have a center in Bali, which is the Regional Capacity Center for Clean Seas, hosted by the Ministry of Environment of Indonesia, which is also a first regional activity center for COBSEA. So these types of digital twinning prototypes, I think, is something which is of interest for us in COBSEA. But overall, I just wanted to leave you with these regional seas and the opportunity for synergies as you move forward. COBSEA in the Southeast Asia region, I think, will be an interesting partner. We would like to use the data for informed policy with our intergovernmental process. And then our current focus on marine litter, which is linked to this global treaty and the global partnership on plastics and marine litter, as well as on in terms of the biodiversity, the UN Biodiversity Lab, I think, which is another very important resource. And then two slightly global in terms of the GEMS ocean activities, which are then linked to the World Environment Situation Room. So with that, thank you very much, everyone, and back to you.
Thank you very much, Mahesh. We have a couple of questions from the online audience. Maybe we can go through them. Take a couple of minutes. Sorry. Okay. So the first question is about, it's really for you, Enrique, how this program can help the nations.
Well, I think this program will certainly be helpful for the nations in terms of providing
No, it's okay.
a proper framework for improving the forecasting services of the nations. We are talking about capacity development. We are talking about delivering as one, sharing tools. All this for sure will create a more robust and more easy to implement forecasting services that will facilitate all the downstream services that will help the economy and the well-being of the nations. So this is the ambitious objectives we have.
Okay, so there's a question about the data availability. I guess this is a question for Dr. Pong. This was already answered, I think, because it was answered that it was mostly for the project at the moment.
I can go a little bit on that also.
Yeah.
I think that here again it's very great to have the CASE framework because you know the situation is completely different from one region of the world to another. We have been in Europe working many years in things like the Copernicus Institute or EMONET, and we have advanced a lot in this framework. But it's not the same situation all around the globe. Furthermore, what is done in Europe is not sometimes, let's say, interoperable with other parts of the world. So even there's a lot of things to work and advance, both in the developing of standards, tools, and training programs.
Then we have a question on, is there any record microplastics in groundwater? I think the answer is yes, but I think this is a question for you, Mahesh.
Yes, yeah, I would have thought that. Yes, of course, microplastics is everywhere. So it's a huge challenge with the macroplastics, the breaking down into microplastics. And in terms of groundwater, in the deepest parts of the ocean, the top of Mount Everest, in the air we breathe. So it's becoming a really big challenge. And recently in Bangkok, we jointly hosted with the economists last week, the Global Plastic Summit ahead of the the INC3 in Nairobi next month, where there was an interesting report released by the Mineru Foundation on the health impacts, because somehow plastics and health, it's not been studied as much. So there was a landmark report, and of course with microplastics in food, everything. So there's a lot of interest in this area, and the research is really booming, and definitely in groundwater. Back to you.
Thank you. And so just, yeah, we don't have, okay, Enrique, last question. We are on time. You want the last question?
Well, I would like just have a question for Mahesh, which is, can you brainstorm a little bit on how you think, after what you hear today, that we can be helpful for COBSEA? What is, let's say, your expectation for OceanPrediction DCC as per today?
Yes, yeah. Thank you, Enrique. And I think we had a good chat earlier on this. COBSEA being intergovernmental, we are sort of driven by the needs of governments who have identified these three areas of marine litter and plastics, the pollution side, the biodiversity side, and then now also looking at climate change. And I think with ocean forecasting in all these three aspects, Enrique, it'll be really good to get some solid, robust data that we can provide. Example is on nutrients, pollution. We are just starting on this because we have 2 UNEA resolutions on sustainable nitrogen management. We are very inefficient. 80% of the nutrients we use in agriculture is lost to the environment and flows out into the oceans. So that modeling, I think, is something we need also help with. So basically, I think in terms of robust data to help with decision-making and policy making, then I think it's something that we will very much want and seek partnership with.
Thank you. That's really important also for us to use this nutrient data in our systems. Yeah. So now the next presentation, so we going to start a session on mapping observations in the region. And so Dr. Liying will start with a presentation on China's ocean satellite and its application potential.
Okay, sorry. Yes, it works. Okay. So thank you, Chair. Here, Dr. Pang have introduced our institute data. So now I represent National Satellite Ocean Application Service, another center, to give the presentation about China ocean satellite and its application potential. Sorry. No, it not work. Yeah, sorry. So now in China, we have the observation capability of ocean in orbit satellite network include 3 series. First is ocean color satellites, include HY1C and HY1D. And the second series is ocean dynamic environment satellites, include 3 satellites, HY2B, 2C, and 2D. The third series of the satellite is ocean surveillance and monitoring satellites, include GF3 and 1 meter SAR-12. And this satellite, China can establish the marine dynamic environment network only 6 hours to monitoring 80% of a global ocean, and 1 meter CSAR satellite will with the orbiting GF3 satellite formed China's first land sea radar satellite. So my presentation includes 5 parts. First is for the ocean disaster monitoring. So every year, southern and the eastern province of China caused by the typhoon disaster. So our satellite measure with wind speed and direction to the weather condition, scatter meters and star data to the prevent and mitigate the typhoon disaster. So the second one is on orbit satellites HY2 series and the CFSat MITOPS BC could together use to monitoring the status of the typhoon operationally. So this scattered meter data have been assimilated to some numerical model, include ECMWF and the GRIPS in China, to improve the prediction performance. So the third one, maybe you pay more attention to the green tide disaster in China. So from 2008, each year, the remote sensing satellite data, satellite data will monitoring the green algae to give pre-warning of this massive bloom. So also include the macroscopic algal monitoring and right tide monitoring. And also the oil spill disaster, also the damage to the ocean and the wildlife habits. So as well as the fishing and the tourist industry. So STAR data could provide the information about the oil spill position and the signs. So several oil spill events have successfully monitored by the NSOAS. So next one is for the ecological monitoring. Next one is marine environment monitoring and forecasting. So NSOAS produced multiple satellite data to fusion analyze some products, include the sea level anomaly, sea surface temperature, and sea surface wind. So the remote sensing techniques also used in the research and the management of the coastal culture area and wetlands. The third one is ecological monitoring. So the invasion of Swadhin flora has increased the ecological problem. So our satellite data have been used in marine ecological protection, such as monitoring of the mangroves and Swadhin flora. So also we have been used to monitor the distribution of coral reefs. So the fourth one is for the resource survey and monitoring. So wind power is pollution-free and renewable resource. So the satellite data could be used to explore the wind characteristics and the wind energy potential of the offshore wind resource assessment and the wind power generation set selection. And the sea covered 2/3 of the Earth's surface. So the ocean fishery also can get the benefit from the ocean water from the satellite remote sensing. And we also use this satellite into the polar negative safety. This we can provide the sea ice concentration to from the HY2 satellite to provide the polar research. So the last one is a case of we in our operational forecast. So we analyze analyze the sea level anomaly to by the method spatial and temporal objective analysis to get together with HY2 BCD, JSON 3 and Series 3 A and B to provide the products like sea level anomaly, ADT, and the geostrophic flow. And we also do the sea surface analyze and produce the data set. So we have a case to experiment to last year for about 3 months. So we checked our data set and together with from CIS and OCTA. So in China seas, we get the better performance. So that's the I just short summary. We have the 3 series ocean satellites data, and China satellites have been successfully used in marine environment forecast monitoring and forecasting. So maybe in the future we'll use more and more satellites in operation. So that's all. Thank you.
Thank you very much. We have 1 or 2 minutes for questions.
So I'm curious to understand how is the connection of all this wonderful constellation of satellites with the Copernicus service at Europe? Do you do some specific collaboration on data sharing, or is there any kind of connection with Copernicus service, with Copernicus satellites?
Yes, in many operational satellites, we in our operational system, we download some data from Copernicus data, and so we also have the collaboration with NSOAS together to use their data and to compare the which is the better. So that's.
Thank you.
Thank you.
Thank you. So it's time to move to the next presentation, which will be by Dr. Kentaro Ando from JAMSTEC in Japan.
Yes, thank you very much. Can I start?
Yes. Your presentation is not full screen yet.
All right, yeah.
Okay, it's done.
Yeah. Thank you very much for inviting me. My name is Ando from JAMSTEC Japan. And so my internet connection from my office is not so good. So let me stop my video, sorry. So my talk is about observation studies in the Western Pacific. And today I would like to introduce some activities, studies in the Pacific. First one is ARGO and PAC. PAC stands for the Pacific Argo Regional Centers, which is operated by JAMSTEC. And second one is TPOS 2020. And third one is CSK2 by IOC Westpac. And the final one, I would like to shortly introduce the Japan Meteorological Agency's long-term observational lines along 137 East. So first one is about Argo. So as you know, Argo already deployed more around 4,000 floats. Left hand is the operate Argo float map at the global scale. And the right hand is new challenges by Argo group, and they started deploy the BGC Argo, biogeochemical Argo, on which the BGC sensors are installed. And in the Western Pacific, we already have several or many BGC Argos. But BGC Argo do not fully install the all necessary sensors. Some floats only install oxygen or chlorophyll or something like that. How can I move to another? Okay. And this is the effort by JAMSTEC. This slide was provided by Dr. Hosoda in JAMSTEC. And this is a scheduled map of Argo, a launching map of Argo float by JAMSTEC in this year. So they use several research cruises for launching the Argo float. JAMSTEC purchased core Argo float. Core Argo float only equip the physical sensors, temperature and salinity and depth sensors. And they also deployed the deep Argo going down to the depth, almost bottom of the sea. And they also launched several BGC Argos. And the color of this track indicate the cruise by Ryofu, Mirai, and Hakuho, and other private lines. And for the BGC and the deep Argo, JAMSTEC used the Seabird BGC Nivis, which was manufactured by US. And this is a little bit smaller and can install several BGC sensors. And our Argo group also used the Ninja float, which was manufactured by Tsurumiseki, Japanese company. This is unfortunately a little bit higher and a little bit weight. And but it can carry the DO sensors and can go down to deeper than the core float. Then, and the JAMSTEC team also operate the Pacific Argo Research Regional Centers. And they developed some application tools to assist the deployment of Argo float. So they try to forecast the location of Argo floats after 360 days, 720 days, and 1080 days by using the numerical model. And and then they try to identify the location they should deploy in the next year or 2 years later, something. And another topic is about TPOS. TPOS started in 2015 by the effort of IOC and WMO. And TPOS 2020 project was ended in the last year, and the purpose of TPOS 2020 project is to, the invigorated, the tropical Pacific mooring systems. Since 1980, middle of 1980s, we have operated tower race by NOAA, and since 2000, JAMSTEC and NOAA operated Tau Triton arrays to monitor El Nino phenomena in the tropical Pacific regions. But due to the crisis to operate the Tau Triton arrays in around 2012, the TPOS 2020 project was studied. And the TPOS 2020 team they invigorated works on the tropical Pacific across the multidisciplinary and mobilized our community through the workshop and conferences. And TPOS 2020 teams published three reports shown on the right, and which contain the recommendation for the design and enhancement of new TPOS. And then, so we developed these reports by using the integrated visions. And we try to use the satellite data, of course, and mooring systems across time scales, allow the co-located ocean atmosphere observations and velocity samplings. And of course, we asked to our group to cooperate and and to add salinity maps and subsurface temperature and salinity, which connect to the subtropical regions. And from the final report, we could make the new configuration of the observing system. So this new TPOS will be composed by the algo float, hydrographic cruises, drifters, USBs, and satellite retrievers, as well as the mooring observation, so TMA, tropical moored buoy array. And this tropical moored buoy array, the map is shown in the middle on the left, and which composed more highly instrumented and capable moored buoy system, and envisaged three tiers of mooring site. So one is tier 1, very much standard, and tier 2 with enhancement of velocity measurement, and tier 3 we call the super site, and then so in the middle on the left, I show the proposed reconfiguration. So looking at the Western Pacific, you may see the enhancement of mooring system in the northwestern Pacific, which is now planned to operated by China. And another feature is to enhance the measurement in a mixed layer observation, and also try to enhance the meteorological sampling. And then, of course, plus BGC measurement in this new configuration. Sorry, I forget. Okay, yes. And also in this TPOS framework, we encourage to participate, conduct process studies. So some experts proposed the process studies in the full area in some areas of tropical Pacific. For example, one of the proposals in the Western Pacific, 7.4.6.2, that is just chapter numbers. In the second report, we have used wave gliders for the measurement of air sea fluxes in the Western Pacific regions. And the third one is I would like to introduce is the CSK2, collaborative study of Crossio, which has been proposed by through the IOC Westpac. Now, the region focusing on is shown on the right top, along the Crossio regions, from the origin of Crossio to the mainstream of Crossio and Crossio extension regions. And the scientific purpose is to understand the Crossio and its impact on global and regional climate and weather, and which will follow to the achieve improved forecast of regional and weather and climate. And the second purpose, aim, is to understanding of Crossio in relation to marine ecosystem variations linked to partially to the effect of front dynamics, climate change, and direct impact of anthropogenic coastal activities. and which flow we believe to manage better regional fisheries and aquaculture along the Kuroshio and adjacent regions, including the local bay and estuaries. And that is a kind of purposes of CSK2. And then after we established the CSK2 under the framework of IOC Westpac, we called the CSK2 project to the member states of IOC Westpac. And then finally, we could collect 11 proposals. And now these were endorsed. And then I do not introduce all as we don't have time. So, okay, sorry. But just mapping the areas of activities on the map. So it is clearly that these activities covers well along the Kuroshio Coast. And and also the proposals coming from the various member states of IOC Westpac. And then maybe you may be interested in about the data collection. We developed the data management information plan for CSK2. And this is still under development, but we plan to have the data portal maybe at least in 2 sites in the regions. And for each PIs of CSK2 project may have the data node in each site. And then so the data portal will guide to the users where the data will be. So data users can access to the data from CSK2. So that is just a plan, but CSK2 has already started, but the data system has not yet developed well. We are in an effort to make it accomplished. And the final one is I'd like to introduce is the JMA line. So JMA line along the 137 East has more than 50 years histories since 1966. So this is a 137 East lines. And then this color indicate the depth to be measured. So in the early stage, JMA measured up to 2,000 meters, but recently they measured more than 3,000 meters or 4,000 meters. So it should be a very variable for all. And this is just a final examples of the impact of these data. So along the 137 East Meridian lines, it can be shown that the PCO2 pressures increasing since early 1980s to the recent. And also on the left, this data also can clearly show the Kuroshio big meanders, which is occurring in the south of Japan. So this monitoring is very beneficial to society, I think. So that's all. Thank you very much.
Yes, thank you for your presentation. Just one information regarding the extension of the TPOS observing network. Do you have already a calendar or at least objective of this tier 1, tier 2, and tier 3 planning?
Oh yeah, so you mean the TPOS? Okay, yes. So based on this design of tier 1, tier 2, tier 3, yes, NOAA and JAMSTEC, try to fit to this tier 1, tier 2, yeah, by the final designs, yeah.
Yes, but
The question was more, do you already know when the tier 2 is going to be implemented?
Oh, sorry, I do not know, but yeah, NOAA's NDBC National Database Center is now, yeah. I heard that in some locations they have deployed somewhere. Sorry.
Okay.
The tropical region, sorry.
Okay, thank you. So maybe let's move to the next presentation on the state of observational studies in the Western Pacific by Dr. Agus Atmadipoera from Indonesia. It's a video presentation recorded with Dr. Atmadipoera from IPB University in Indonesia.
Hi, good morning, everybody. I am Agus Atmadipoera from IPB University, Bogor, Indonesia. First of all, I would like to Swadhin for inviting me to this talk on ocean prediction, West Pacific and marginal seas also, and East Asia. My title here is Hydrological Properties in the Banggai Maluku Sea from Bude Cruise. This program is a Bude program is endorsed a program by IOC UNESCO Westpac, CSK2, cooperative study on Crucio and adjacent seas. Here is my colleagues. Okay, just to look at the documentation from the cruise. This is the maps of the cruise track. Ship times is financed by the BRAIN. This is National Agency of Innovation Agency. And here using onboard Barunajaya 8 with about 58 sampling station and port call from Ambon to Ambon, Maluku, Indonesia. As introduction, bifurcation of the North Equator current here to be a northward Crucio current and a southward Mindanao current here. We'd like to talk the extension of the Mindanao current here that feeding to be Indonesian through flow via the Sulawesi Sea and also via the Maluku Sea and also the Mindanao current feeding the North Equator counter current. Here, for example, around this port entry portal of the through flow, for example, between Talaud and Halmahera from Lee paper, it is found that the mean flow is a direction to the northeastward in the upper 400 meter. Also, the mean flow is about 10 sphere drop in this region, showing the seasonal and seasonal variability. And also in this region, this is dominated by the North Pacific water, but also some period times from the South Pacific water. Here, for example, along channel structure of the flow, showing the variability fluctuation in the upper 400 meters. And this is, for example, the temperature salinity relationship showing the both from the South Pacific water and also from the North Pacific water. In the Maluku Sea here, in the northern entrance of Maluku, there's a main flow about 2 sphere up to the Pacific that is outflowing, not entering to the Maluku Sea. But in the middle and intermediate layers, this is the southward main flow to Seram and Banda. Also, this is suggests from this paper, there's anti-clockwise circulation in the middle layer, so creating the upwelling in the basin scale here. In the southwestern part in the Maluku Sea, there's upwelling, so coastal upwelling here with for example, here during August or southeast monsoon period, this is the maximum chlorophyll and also the minimum basal temperature. So with the southeasterly monsoon wind in this region. And showing the source here seasonal of the chlorophyll and wind stress. And vertical structure of the current showing the upwelling jet here and also the circulation of the through flow in this region. So BUDE program is a multidisciplinary study on physical sonography, paleosonography, biogeochemistry, marine environment, and ectoplankton and fisheries acoustic. So we have about 9 sub-themes here of the objective of the BUDE. But in this talk, I would like to focus on hydrographic properties or stratification of through flow water and also ocean circulation. This showing the study maps here, the cruise track from the northern Banda to the Mati Mas Strait, Seram Sea, and also in here in Maluku Sea. We have about 40 city casts. Also along truck seaport as a seaport NDCP. Yeah. We follow the data processing analysis using SPA and LIBOR for the seaport ADCP. Also, we are trying to look complementary data set from ArgoFloat, surface wind field, and also satellite data set, and trying also to configure the high resolution ocean circulation model using the CROCO system. And here, for example, the result from this study, for example, seawater distribution in the 10-meter depths, we can see potential temperature, salinity, dissolved oxygen, and fluorescence. And here, the indication showing in this part is the center of the upwelling with the salinity temperature minimum, relatively high temperature, and also relatively low oxygen, and also a high chlorophyll concentration. And also in this northern part, we can see here the fresher waters and very salty waters here. So this is coming from different water masses coming from the North Pacific waters, and here from the South Pacific water through the Halmahera Sea. Here is a scientific distribution on surface density between 22-24.5, showing the upper layer near surface waters is very fresh water in this region. And follow in the subsurface 22.5, we can see the transformation of the waters from the eastern to the western part here. And also in the lower part here and 24 surface density, we can see also transformation from the northeast to the southwest part here. And it is very clear here in the Seram Sea and the Manipas Strait and Banda Sea, we can see very relatively salty water here. So this is showing the North Pacific water and the South Pacific water origin in this region. Also, we can here we found the coastal upwelling signature here, where in the central upwelling we have the transect here along the southern boundary to the western boundary. So the upwelling center here, just in the corner in this transect, we can see here the fluctuation, vertical fluctuation of temperature, salinity, and also potential density. For example, in this region, in this part, there is a fluctuation, the outcropping of the isotherm 28 and this is 27. And also, we can see here the outcrop of 23.5 PSU of salinity. Yeah, from about here we can see from the subsurface about 200 meters, and also density you can see clear here. But in this region, just in front of a strait, we named here Bote Strait, there is intrusion of the water, much warmer and fresher waters through the Maluku Sea. This is from the southern part, northern Banda. So there is a inflow of warmer freshwater Banda via the Bottom Strait that disrupts the Bangai upwelling normally, because normally this is in this region is we have the outcropping of the temperature, salinity, and here also from this of oxygen fluorescence, we can see this is quite consistent. There is a relatively low oxygen and high chlorophyll concentration here, showing the upwelling process in this region from about 200 meters to the subsurface. This is the stratification of the truffle water. We have 4 sections here, but showing the eastern part here, showing the different water masses. For example, this is the local fresh water, and at the thermocline we can find here the North Pacific subtropical water origin from the much stronger from the north to the south. So this is from the this is south to the north, and also in the intermediate layer we have around 26 potential density. We have a North Pacific intermediate water here. It's very clear, and this from the north to the south. This is there is transformation. That is spatial variation from the north to the south, and below this around 27 we have an Antarctic intermediate water here, but relatively weak signature of these water masses. So this is the TS diagram of the structure of water masses in this region. But if you look at here, the section 3, so 1 to 3, just northwestern part in this region, we have the much weaker the North Pacific subtropical water here compared to the eastern section. Also, North Pacific intermediate water here. Yeah. So there is also sporadic like core of the North Pacific subtropical water here. This means this is also not only the north-south variation of the water masses, but also from east-west or zonal variation of the truffle water. But in this point, Maluku Sea is dominated by water coming from the North Pacific origin compared to the southern part. Here, for example, in this region, yeah. Also from the days of oxygen, this is high days of oxygen. Also here, for example, chlorophyll A. In the eastern section, we have the depth of chlorophyll maximum is below at the subsurface, and also but in the western part, just for example here near the center of upwelling, we have the chlorophyll maximum depth is just near the surface, sea surface. Yeah. And here the TS diagram showing the structure of the water masses. For example, all the data set from the Maluku Sea, we have here the North Pacific subtropical water with the salinity maximum. Also here North Pacific intermediate water with salinity minimum around 26.5. And below this, I think this is identified as the Antarctic intermediate water with relatively high oxygen. In contrast to the southern part here in the Seram early manifest Strait, we have only found here the signature, a strong signature of the South Pacific subtropical water with salinity above 35 PSU. Compared to this Maluku Sea, only we have here, for example, 24.6 PSU, but this is above 25 PSU. For current observation, here, for example, between the upper 100 meters and between 100 and 200 meters, we have the, this is like clockwise circulation in the Maluku Sea, but between 100 and 200 meters, this is seems like anti-clockwise circulation. So in this, this is two layer. Because we still have the between 300 to 200 to 300 and 300 400 meters. It's quite complicated, the kind of the circulation pattern here. But in this is very clear. There is clockwise and anti-clockwise circulation in this region. Also, we can see here the very strong shear currents in the near the Livermatlasset here and the Seramsi here to the south. This is representing the through flow coming from the Halmahera Sea. Yeah, but here it is supposed to be coming from the north and take the recirculation of the through flow here. Here, for example, the vertical structure of the current in the Livermatlasset here, we can see very strong in the southern part here, as showing from the current factor in slide before. But in the northern part here, near the Livermatlasset, very strong, like northeastward of the current here. Yeah. So for the zooms of this talk, we found a weak intensity of Bangga upwelling in the southwestern study area, but this intensity of upwelling is disrupted by inflow of fresher and warmer water from northern Banda via the Bote Strait. I think this is new finding. We cannot find any publication on this part. There is intrusion of the water coming from the Bote Strait to the Maluku Sea. Also, the wake of intensity is hopefully modulated by interannual variability, because during last year, 2022, this is the strong El Nino. This means to modulate to be a weak upwelling intensity. The third point is the North Pacific water is dominant Maluku through flow. There's also South Pacific water in the Seram and northern Banda Sea. This is coming, coming from the Halmahera through flow. We found also zonal variation of the through flow in the Maluku Sea, which is the clockwise and anti-clockwise circulation in this region. Hopefully, the next study, we are going to configure high-resolution model circulation in Kroko to investigate more detail on the mechanism of propelling during the, for example, interannual variability. Why is during El Nino a weaker upwelling intensity from here, but during La Nina, but during El Nino, this is 22 is La Nina, very sorry. La Nina, but during El Nino, for example, 2015, very strong upwelling intensity can appear in this region. So I think that's all of my talk. Thank you very much. Once again, very sorry because we have also seminar here, so we take the Zoom recording video. Thank you very much. Thank you.
Thank you. So that was the presentation. So we can move to the next and last presentation of this session by Dr. Young-Gyu Park, who will show us an overview of selected coastal and open ocean observational programs in Korea.
Yeah, thank you for inviting me to this interesting workshop. As the title says, I will just explain our activities rather than results. And this is work by myself and our collaborators at Korea Institute of Ocean Science and Technology. So this is the observational side. I will explain a little bit. So the first one is this crucial extension, number one. I think that's related to CSK2, Dr. Ando mentioned in previous talk. But The main purpose of the first project is looking at the variability of crucial using current meter mooring and instrument called PICE. The second part is for the crucial extension. We were interested in variability of there. Third one is for the Western Pacific. The focus is air-sea interaction, and we also had moorings there. Number 4 is for the Eastern Bering Sea. We believe that the extreme event in Korea was initiated in Western Pacific, or atmospheric blocking initiated Eastern Bering Sea. So that's the reason we selected those 2 areas. And the last one, the 5th one, is for the coastal station. It's a very near the coast. So it's a kind of bit of contrasting theme, but I want to show you all those. So for the open ocean part, I think I will cover about at least more than 50 of our effort for the physical oceanographic work for the Pacific Ocean. So I'll talk about in detail for the individual one. The first one, crucial thing, was started 2015. Sorry. It's a joint work between Japan, China, Korea. The training ship from Kagoshima University was used. The pointer is so there is a along the shelf there is a crucial and nuclear current, and they interact, and the interaction is rather complicated. So they want to figure out what's going on. So more or less, the thick line is a known part, and dashed line is more or less unknown part. So they deployed current meter mooring, PICE, and through all those studies, they figured out what's going on there. This is still going on. Thank you. So this project has been evolving quite a bit. So once they figure out some part, they move to different parts. So as you can see from the table, they moved from one side to another side to figure out the variability of that current system. From 2019 to 22, that's the period for the pandemic. So there's a huge difficulty in bringing instrument and recovery, but it survived. So it's still going on. And as I said before, I think this is related to CSK, and I think it could be continued. The second part is for the crucial extension. This was started 2017 and ended rather abruptly in 2019. So we were interested in physical and biogeochemical variability of the crucial extension system. Crucial extension moves north and south depending on climate change. So for example, in glacial period, it was shifted southward, but now in the warming world, it's moving northward. And because of that movement, the biogeochemistry of the system changes. So big plankton is decreasing while small plankton is increasing because of scarcity in food. So we want to see both physical and biogeochemical changes in there. So to look at the physical changes, we put tall mooring and also put PICE. For long-term scale, like glacial to interglacial timescale change, we took sediment core. For biogeochemistry part, we want to quantify carbon cycles, so we put sediment trap there to measure sinking carbon fluxes. We also took water sample to look at the ecosystem and the nutrient cycles. So we also measured microstructure to see what small-scale process is influencing those variabilities. So this is an example of our cruise track in 2017, sorry, and the design of a mooring we deployed. I just want to briefly show you some of the results we got. In this case, we are interested in energy input from the air to the ocean. So the first column and the first line represent input of wind input to the ocean from observation and from a SLAM model. And this middle row represent what's the energy input by near inertial internal waves from the surface to the deep ocean. So the first one, the red one, that just occurred a year or just once throughout the year, and that explained like 70% of energy input from the wind to the ocean. So just one big event, and that's all. And this part is a crochet extension area. It's a meandering is quite strong. So what I'm showing you on the top left-hand side is sea surface height. So the thick red line represents the axis of crochet extension, so it meanders a lot. And the south represents our mooring site. And our mooring site was within cyclonic eddy. Near inertial internal waves interact with mesoscale activities quite strongly. And if you do not include that properly, energy input cannot be estimated properly. So there are series, but there are not many observational evidences. So what we found is, as the series says, cyclonic eddy made wave propagate much faster and trap energy within the eddy. So that's the reason for big energy input during one event. Another instrument we deployed there is called PICE. It sits at the bottom. It sends sound waves from the bottom to the surface and measures return time. So it's like this, return time. It's a travel time. So it's about 4,000 meters, so it takes about 6 seconds from bottom to the top and return. What's the speed of sound waves in the ocean depends on density. So as you can see, the small fluctuations in travel time reflect change in density, which is caused by, of course, change in temperature and salinity. So if you could invert that travel time to temperature and salinity profile, so it's we get that temperature profiles every 30 minutes, such a high resolution temperature profile. So as you can see, longer travel time near the end of the time series represent cold water. That's due to cyclonic eddies. So we are looking at those structures and some variabilities I will skip. For the Western Pacific part, that was started 2013, 2020, and it'll finish sometime this year. So we have hydrographic survey and wave glider and superstation, and we also measured the mixing. We deployed Argo floats. We also deployed surf drifters with help from NOAA drifter program, and radios on there to get atmospheric sounding and wave gliders to get air's interaction more in detail. So this is one thing we are focusing on, such a daily variation, since we measured atmosphere and ocean at the same time with high temporal resolution. We believe we could understand the high temporal resolution variation of the ocean, atmosphere, and their interaction. And we are looking into the data currently. So upper part is for the air and lower part is the ocean. So for the Eastern Bering Sea, that was started 2019 and ended like 2 weeks ago. I went there and recovered everything, so finalized our observation. It's a similar thing for the West. It's very similar to what we did for the Western Pacific. Unlike previous expedition, for the previous expedition, we had our time like about 20 days or 30 days for our own research. But for this case, we got just 2 or 3 days on our way to Arctic Ocean. So we just had very brief time to deploy instrument and recover. Here we recovered various instruments, and yeah, this area is a rough. So I just want to show you one example from our observation. We deployed wave gliders to measure air interaction. The boat get there during July and return in October. So plan was deploy instrument in July and recover in October. Last year we meant to recover that in October, but it was so rough, so we couldn't do nothing. The three of us got there, get in the boat, couldn't do, so just have seasick for 2 weeks and return to Korea. And that's the track of the wave glider. So it worked quite nicely until middle of September, October, and that area was hit by typhoon. And sure enough, the instrument was half destroyed. And the figure shows pressure and wind gust measured by wave glider. The lowest pressure was 960, and the wind gust was more than 130 kilometers per hour. So we thought everything would be completely destroyed, but half of the instrument was survived. But the instrument stopped recording anything since then. But luckily, we were able to navigate the wave glider to Hawaii, to the company, and recovered half destroyed. We recovered half destroyed wave glider in Hawaii last April. And the repair cost is half of the price.
Wow.
The final thing is our coastal station. That was started 16 and continued until 22. It's kind of small, but the buoy in the middle is part of the observation system, and the buoys in front are from the aqua farms. The reason I'm showing you that is as follows. Previously, if we deploy some instrument in coastal area, local fishermen complain because instrument could entangle their gears. But now it's changed. They come to us and ask our results because they feel the changes in the ocean. So to some degree, through this project, we realized the changes and the impact of changes to local fishermen. So the site is further down near the south. It's a beautiful area filled with many islands, and of course, lots of aquaculture farms. This is about around 40-50 meter deep, and we deployed a vertical profiler. It's a Russian vertical profiler named Aqualog, and it works very nicely. We could put CTD and ADCP there. So we set it move up and down 1 hour or every 1 or 2 hours. On this coastal area, marine heat wave is quite severe during summertime. So that's one of the targets we want to see. So started 16 and 2022. It's all labor intensive, so we finally stopped last summer. So everybody complained about that. So the figure I'm showing you are temperature and salinity. It's very interestingly, they are equivalent. If I take out the labels, you won't see the difference between temperature and salinity. So the shading is temperature, and the contour lines are salinity. That area is governed by freshwater from the Yangtze River. So during summertime, freshwater enhances stratification, and that traps the heat at the surface. So warmer goes and disappear along with freshwater from the river. Unlike from marine heat waves in other areas, this marine heat waves at the surface is related to high oxygen because water from the river contains lots of nutrients. So in this figure, I show you salinity, which is in contours as before. DO is shading. So freshwater means red one means high in oxygen. So we thought, well, it's good. But if we look at down below, the bloom will go down and they die. So that causes low oxygen. So it's somewhat different from other situation. So this is my final one. We have conducted many observations and we are now analyzing the data, focusing on ocean interaction. The data we got from, especially for the atmospheric sounding, goes to atmospheric model to study the impact of data assimilation. We also have a forecasting system along with these observations for the regional and for the open ocean. So this is all I have. Thank you.
Thank you. I think we are, yes. We will take questions online maybe because it's time to close for today. And yeah, thank you very much. Of course, all the questions will be answered. We have questions online. So, are the satellite products freely available for research purposes? This is a question, I guess, for the Chinese satellites. You have answered online, okay. Okay. So chlorophyll A, SST, sea level, SAR, oil spill, and so on have been used for research. You can browse the website, okay. But it is not yet shared on another platform. Most of them. Okay, good to know. Thank you. Most satellite data is free to public, okay. And then, do we have other questions? No? Ah, okay. Okay, so maybe we can stop for today and meet again to get all together for the session A2, the ocean forecasting value chain that will take place tomorrow at 8:30 Central European time. So please join us tomorrow. And we'll start with ocean forecasting on the region and then downstream services on the region. So thank you. Thank you, speakers. See you tomorrow.